So we just discussed the summary of ideas regarding a singleton design pattern, and we found out that it may be beneficial to have an elevator bank implemented as a singleton in our building elevator simulation program. So the next idea after singleton is that we may also discover that we may want to have another constraint in the system, expanding the idea of singleton to something different, that maybe we want to have a, just like we were able to limit the number of instances in the singleton, now we may want to be able to limit the number of instances of a certain class to a certain number. So basically we want to specify that we'd like to maintain a pool of objects of specific size. So somewhere here we want to be able to have an object which keeps collection of all of these objects, okay, and maintains a set of objects which are called subjects officially, and use it as an object pool. Okay, so the next thing to discuss for us is object pool, where we basically want to now control not a single instance of an object, but a specified number of objects. Okay, so that's the next thing to talk about, the pool of objects. So this is our handout, and object pool design pattern is also known as resource pool or N-ton, basically because you want to maintain a specified n copies of objects of specific type, and you want to control object creation in such manner that we maintain them all in a pool. So what is the benefit of having this type of design pattern in the system? There could be multiple benefits. One of them is that, for instance, creation of specific class may be taking a long time. So we want to maintain it as just avoid extra times to create a copy. So for instance, we create a copy of an object, and we may be able to use it just for a few seconds and then destroy it. Or instead we may decide not to destroy it, but place it back in the pool. And another situation could be that the rate of instantiation is high. So imagine that we have here in our elevator simulation design, that we have this simulation scenario class, right? So we can have a simulation scenario. Okay, so we may have this class in the system. And this simulation scenario creates visitors. Basically, creation of visitors and giving visitors an agenda to interact with the rest of the system is pretty much the driving force in our simulation. So of course, simulation scenario may want to create a lot of visitors, and visitors enter and exit the building. So the rate of instantiation of visitors is pretty high. It could be thousands or even tens of thousands of times that we want to run the simulation in accelerated time manner to see some statistics on how the entire configuration of the elevator bank with the set of elevator behaves in a certain environment. So there could be a lot of times we create these visitors, but it may be possible that maybe only less than 100 of these visitors essentially participate at any given time in the simulation, or it could be restricted to another level. So then maybe that what we want to do is that instead of destroying the visitors as soon as they exit the building, we want to retain them, and then we can implement the simulation scenario as a reusable pool of reusable visitors. Okay, so that's the idea. That's an example where we just don't want to create new object and destroy them. Instead, we want to be able to keep them in memory, and when we instead of creating brand new visitors the next time the simulation scenario wants to create new visitors, instead the unused objects may be already found in the pool, and so we may be able to reuse them again. So that's a possibility in the design of our elevator application. So this is the UML diagram of reusable pool. And so if I'm using simulation scenario as an example of a reusable pool, so it has to have a collection of reusables. Okay, so in our case, reusables are visitors. And of course, it's some sort of list of visitors. Okay, so here this association right here indicates that we can have a lot of visitors created at runtime by the simulation scenario. Now, the simulation scenario itself oftentimes is essentially to become designed as a pure reusable pool design pattern. It should be in itself a singleton. So that's why we say get instance. Okay, so we will indicate this by adding get instance operation. Okay, so we'll say get instance, and get instance will return back a copy of simulation scenario. Okay, so simulation scenario in itself becomes a singleton. Okay, so this becomes a singleton class. So then the way we create new visitors is that we say acquire reusable. In our case, we can say acquire visitor or release visitor. Okay, so I think because we envision visitors as being reusable objects in the system, let's just use this terminology and say the next method we can say acquire visitor. Okay, and this of course will return a visitor, and then also we can say release visitor, and this method will take basically visitor to be released. Okay, so something like this. And we can also control the maximum pool size. I'm not going to add this operation here just to keep it to a minimal design, but this is the idea. Essentially, once again, I just want to summarize this idea by saying that my plan is that perhaps simulation scenario does not want to create brand new visitors all the time. When the visitors are exiting the building, we don't want to destroy them and dispose of them. Instead, we will just go through this interface saying release visitor, and the visitor will be used as no longer active. Okay, and so the next time when we want to reactivate this visitor, we say acquire visitor. If visitors don't exist, the new copy of visitor will be created. But first we will check this pool of reusable visitors, and if we find the one that's not active currently, then we can reuse it and put this back to reconfigure it and let it go back into the start participating in this simulation.